My name is Mahmoud Taha. I'm a distinguished professor in the Gerald May Department of Civil, Construction and Environmental Engineering. My main research focus is how to actually get the typical construction materials to become more living elements. How can these materials have some sense, type of self-sensing, self-healing, and recently we looked at how can we actually add to it some cognition, such that these materials would be able to sense the fact it's aging or damaging, would be able to inform us about that, so we can interfere to improve the structural safety, resilience, and we also have been looking at how can we make these materials more sustainable, such that it would have good environmental impact and last longer for serving the purpose it's being used for. The social and economic benefits of the materials research is, of course, altering the way we are building things. From the social point of view, first is if we can make our materials to last longer, then these materials can allow us to develop more affordable structures for people, make it more economically viable, providing more housing infrastructure for people at large worldwide. And that's part of course, the economic impact as well of it. The other thing is when we try to use some of these materials, like the application we are trying to use some innovative materials we are developing for stopping methane emission, that has a much bigger global impact, both on the social and economic side, because if we can help in reducing the methane emissions, that will allow us to stop the climate change, stop a lot of the changes that's affecting people's lives worldwide. The climate change is a key problem we are trying to solve with the technology. So we developed specialty nanomaterials, nanomodified polymers specifically, to actually stop methane emission from abandoned oil and gas wells. We took this technology from the research lab. We started this technology 12 years ago. We took it from the research lab at UNM into a startup company at Yes Nano, where we actually successfully sealed so far 25 wells in the US and Canada, stopping methane emissions in these wells. Successful application of this at a large scale will definitely help in dropping methane emission globally. And I think this is an important target because we all see the climate change features and effect, and we think we can have that small help by the technology to reduce methane emissions. We focused for long on the use of nanotechnology to change polymers and concrete, two major materials in both infrastructure and in aerospace and in many applications. We believe that if we manage to add some of the features I spoke about, like self-sensing, self-healing, self-cognition, that will allow us to drop the costs of these materials for construction, will allow these materials to last longer, will allow it to have a smaller impact on the environment. So at large, we make a new generation of materials for the future that is with minimal environmental impact and maximum social benefit to people. This research, when it started in 2012, was through a collaborative research between the University of New Mexico and Sandia National Lab. That collaboration helped us to be exposed to a lot of industrial, big, large companies that have typical collaboration with the national labs. So that gave us an opportunity and exposure to showcase our technology, and we actually were invited to go and try our technology in Switzerland by a big consortium of companies. And thanks for this to Sandia National Lab. Being at the University of New Mexico and the School of Engineering was an outstanding opportunity because it gives me a lot of freedom to select the research of interest to me and to follow the work I see of value. And I think I was a very lucky man to actually do the work that I consider as my hobby and then being paid for it. So the University of New Mexico and the UNM Rainforest and a lot of the facilities and opportunities created here in New Mexico helped me doing this. So I'm very thankful for that opportunity.